We're going to talk about constant rate of change. In our previous one, we talked about how to convert between system from customary to metric system, metric to customary system. So let's look at this example. Cassandra used 2 and 8/10 pounds of ground beef in a recipe for hamburger casserole. Ooh, hamburger helper. About how many kilogram is the mass of the ground beef? So if you go to England or Canada, they don't go to grocery stores and say, give me 1 pound of beef. They'll say, what? It's like, give us 1 kilogram of beef or something like that. So let's see what this is. So it's pounds and kilogram. If I go back to my old chart, this is what we'll be using. There's 4,536 10,000 place kilogram per pound. However, we need to build up from 1 pound to 2 and 8/10 pound. Oh, goodness gracious. Ugh, a lot of multiplication right here. So what is 4,000? I'm going to multiply without the decimal. I'll worry about that when it's time. What is 4,536 times 28? I predict that the decimal point will be 5 places. So let's see this. 8 times 6 is 48, carry to 4. 8 times 3 is 24, plus 4 is 28, carry to 2. 8 times 5 is 40. Plus 2 is 42, carry to 4. 8 times 4 is 32, plus 4 is 36. Let's go to the tens place. 2 times 6 is 12, carry to 1. 2 times 3 is 6, plus 1 is 7. 2 times 5 is 10, carry to 1. 2 times 4 is 8, plus 1 is 9. It adds up to 8, 10, carry to 1, 10, carry to 1, 7. 1, 2, 7, 0, 0, 8. Ugh, so many digits. But where does the decimal point go? It goes 1, 2, 3, 4, 5. Tenth place, that hundredth. Tenth place, 100,000, 10,000. The 100,000th place, or just 5 digits. So the answer will be 1 and 27008 kilogram for every 2 and 8 pounds. So let's go look at constant rate of change. There was an old woman who lived in a shoe. She had so many children, she did not know what to do. So she decided to hire me to babysit all her little kids. Oh, goodness gracious. But you know what? I'm very cheap. I only charge $4 for every hour, so less than minimum wage. So, however, if they come for me, I'll charge $8 for every 2 hours. Then I'll charge $12 for every 3 hours. Do you see a pattern here? Is a constant one. The pattern keeps going. I think his next will be $16 for 4 hours. $20 for 5 hours. Seems like interesting. The old woman wants to determine if the number of hours of Joe's babysitter is related to the cost. So let's see. Every hour, I charge $4. So another hour, I charge another $4, it'll be $8. Another hour, I charge another $4, it'll be $12. Another hour, I charge another $4, it'll be $16. Another hour, I charge another $4, it'll be $20. So the cost depends on the number of hours. So down here, what would you label this? I'm going to label this hours. And the side will be cost. Because this cost depends on the hours. This is our x-axis. This is the y-axis. So let's label the axis. This is hours. Whoops, almost got it wrong. I wrote it up there. X-axis is hours. It's about time. And the side will be cost. As the hours change, the cost will change with it. I think someone in my other class was saying science. I'm not really big in science, but it should be because I like technology. But they're telling me this is the independent. I heard someone say that in my other class. This is the dependent. So that's something about the variables. I don't know. Sixth grader telling me all about science, how we're graphing stuff. All right, so let's go back to our table and let's graph. For 1 hour, I charge $4. For 2 hours, I charge $8. For 3 hours, I charge $12. For 4 hours, I charge $16. For 5 hours, I charge $20. Wow. If you look at it, it's steadily increasing, but it seems like it's a constant. It's a very steady line if you hit connected the dot. It doesn't deviate or go away from this constant line. So let's go to this one. What is the cost per hour or unit rate charged by the babysitting service? Let's go back to my table. It seems like I charge, remember, a unit rate is where 1 is the denominator, it's per something. It seems like I charge $4 per 1 hour. That's my unit rate. So from your graph, pick any 2 order pairs from the graph. I'll pick this one, 1, 4, and 2, 8. Let's go. Okay. So 1, 4, 2, 8. Again, 1 hour is $4. 2 hours is $8. How much does the y change? Does the y change from 4 to, again, x is the first number, y is the second number. Does y change from 4 to 8? It changes by 4. Does the x change? Does the hour changes from 1 to 2? It does change by 1. So it changes from 1 to 2 by 1 hour. It changes the dollar amount by $4. Hey, isn't our unit rate right there? Interesting. So the first 2 order, let's go to number 5. The first 2 order pairs on the graph are 1, 4, and 2, 8. You can determine the rate of change by writing the ratio of the change in y to the change in x, or this. So what we did, we just found the rate of change. How much is it, the graph is changing steadily. So what did the y change? It changed by $4. What did x change? It changed by 1 hour. So determine the rate of change. Very soon in upper grade levels, you're going to learn something called this. Delta y, delta x. It's delta, or this, means how much the y is changing. How much is the x changing? You will learn this in algebra, in 8th grade algebra. So let's go back to it. So how much did the y change? It changed by 4. How much did the x change? It changed it by 1 hour. Or, if you need to do the math, how much did the y change? 8 minus 4. $8 minus $4 is $4. How much did the x change? 2 hours minus 1 hour is 1 hour. So what does this mean in word form? If you look at your graph, or let's look at a table. As you look at a table, what can you tell me about this? Is it changing $4 per hour? Increases $4 for every hour I put in here? It seems as though it is. Let's look at a graph. Is it changing? Every hour I go, it increases $4. Every hour I go, it increases $4. Or another way to say, it increases $4 per hour, $4 per hour, $4 per hour. So in word form, what does it mean? It's $4 per hour. It increases $4 per hour. So that's what I charge. I charge about $4 per hour. So let's look at, for example, Miss Meyer also charges. She is a mother, so she gets more money because she has more experience than I do. So she charges $6 for 1 hour, $12 for 2 hours, $18 for 3 hours. Can you predict the next amount? Did you say $24 for 4 hours? Very good. What about the next one? $30 for 5 hours? So what are you saying? What is the unit rate? The unit rate is, she pretty much charges $6 per hour. Because it's the same for this one, $12 for 2 hours. If you break it down, would that be $6 per hour? It will. $18 for 3 hours. If you break this down per hour, would that still be $6 per hour? So it's constant change. So it's a constant rate of change. So every time she charges $6 per hour. So she charges $6 per hour. And we can do this mathematically, if you would like to. So 1 hour, she charges $6. In 2 hours, she charges $12. So what is the change in y? Change in y from 6 to 12. It changes by $6. What is the change in the x? It changes by 1 hour. So it's $6 per hour. So what is a rate of change again? A rate of change describes how one quantity changes in relation to another quantity. So we looked at in the example, we looked at how hours change by hour, and we see how the dollar amount keep changing. So, and we see how they relate to each other. The way you can find it, most of it, you can look at it and figure out without using this formula. But if you would like to use a formula, it's looking at the change in y, the change in x. So if the rate of change is the same for several quantities, it's called constant rate of change. So as you can tell, in this one, it is changing the same amount as you keep going by hour. In this one, in Ms. Meyer, it keeps the same rate for each hour. So it's constant rate of change. So let's look at this example. Imagine someone drove 3 hours, 150 miles. 6 hours, 300 miles. 9 hours, 450 miles. And 12 hours, 600 miles. Label the axis. So what do you want to call the axis? You know what? Let's go back. So I see hours and miles. I'm going to label it hours. If this is the one that's changing, and that way will determine the miles on the side. So, graph the data on the coordinate plane on the next page, or this page. So, let's go to hours. What do you want to number it by? What do you want your scale to be? You want an interval? You want to make it by 2s, by 3s? It really does not matter to me. You know what? I'm going to do it by... We don't think we have enough space to do it by 1s. 5 would be 2. I'm going to do it by 2s. 2 hours, 4 hours, 6 hours, 8 hours, 10 hours, 12 hours, 14, 16, 18, 20. And then aside, what do you want to do an interval over miles? You want to do it by 10s, by 20s, by 50, by 25, 100? You know what? I could do it by 25. You know what? I'm going to do by 50s. So this is 0, 50, 100, because I have to go up to what number do I need to go up to? I need to go up to 600. So 150, 200, 250, 300, 350, 400, 450, 500, 550, 600. Ooh, good guess. You know, if I'd done it by hundreds, then the graph would be too low. If I'd done it by 25, there wouldn't be enough space to do up to 600. So let's use a red pen. So let's go back. I think it said 3 hours, a person travels 150 miles. So here's 3 hours, 150 miles. In 6 hours, they travel 300 miles. In 9 hours, they travel 450 miles. And in 12 hours, they travel 600 miles. Wow, if you look at this line, if you had connected it, does it look like it is changing the same amount as you keep going? Is it a steady, constant line? It does to me. So what is the unit rate? Let's go back. It's right here. What is the unit rate? Per hour. So what do you notice? Every hour, it goes up by what? No, let's go back here. Well, we know they do 150 miles for every 3 hours. But I want to know, what is the unit rate per hour? How many miles per hour? So if I break this down I need to break it down by dividing by 3. You get 50 miles per hour. That's the unit rate. Is it really going 50 miles for every hour? Let's see. In the first hour, it goes up 50. Next hour, in the second hour, it goes up another 50. That's 100. Hey, it is. In the next hour, the third hour, it goes up another 50. It'll be 150. So it's 50 miles per hour. What is the constant rate of change? What is this changing? Well, I kind of got this because from what I could tell, it looked like it's going up 50 miles every hour. But you know what? Let's use our formula. In this one, the ordered pair is 3, 150. And in this one, the ordered pair is 6, 300. So we go back. It says find the rate of change is a change in y and a change in x. So is y changing? It changed from 300 miles to 150 miles. So how much did it change? It changed by 150 miles. And the next one, You had 6 hours and then went dropped down to 3 hours. So it changed by 3 hours. So can you break this down? Can you simplify 150 over 3? You can by dividing both numbers by 3. So the rate of change is, again, 50 miles for every 1 hour. That's the unit rate that we just got right there. So is it really changing? Is it every 50 miles makes 1 hour? It does, because if you go to the next example, if you go up 50 miles, it'd be the 7th hour. If you go up 50 miles, it goes to the 8th hour. If you go up 50 miles, it's the 9th hour. So our rate of change is 50 miles for every hour, per hour. So how would you write this in Word? The car travels at a constant rate of 50 miles per hour. So this is what's happening to our graph. It's keep going up 50 miles per hour. So, next example. This is about renting a movie. So we have movies and we have cost. So let's use it. One movie costs $5. That's pretty cheap. No, I don't know, it depends. 2 movie is $10. 3 movie is $15. So, before I do, what can you tell me about the cost per movie? It seems like it's cost $5 per movie. Is that for each one? Is this a constant line? Is it a constant rate of change? Is the line steadily increasing at the same pace? It looks as though it is. So is it $5 for every movie? $5 for every movie. Another $5, it gets you another movie, the second movie. If you go up another $5, you get a third movie. I think it is. So what is the unit rate? The unit rate is $5 per movie. What is the constant rate of change? How is the y changing and how is the x changing? So let's look at a y. You have 10 and 5. Is it changing? So is the dollar amount changing? It's changed by $5. Let's look at the hours. From 2 hours to 1 hour. Is it changing? Changed by 1 hour. So the constant rate of change is 5 over 1, or 5, as you can express it in word form, is $5 per hour. So is it really going up $5 for every hour? Let's go back and look at our tape graph. Just make sure. Does it go up $5 an hour? Yes, it does. Does it go up $5 an hour? Yes. So that's why it's a constant rate of change. So in the next example, if you had to try to guess on the 4th movie, will it go up $5 an hour? That would be $20 for 4 movies. So the graph represents, let's try our next one. Now we just got a graph by itself. The graph represents how far Toby biked given the number of weeks he has been biking. Determine the constant rate of change. So what is happening in this graph? It seems as though it's 10 miles 1 week, and 20 miles 2 weeks, 30 miles in 3 weeks, 40 miles in 4 weeks. Can you predict the next one? I think the next one will be 50 miles in 5 weeks. It seems like it's increasing 10 miles per hour. Is it going up 10 miles for every hour? 10 miles for every hour? 10 miles for every hour? So in word form, I would say it's increasing 10 miles per hour. That's the rate of change. It's changing from 10 miles per every hour. And that's how I was able to predict the next example. It increases 10 miles for every hour. So the constant rate of change is 10 miles per hour. That is what's happening to the graph. Let's look at next example. Determine the constant rate of change. So in 4 months, it grew 8 inches or something. The next month, it grew it grew to 10 inches. The next month, it grew grew to 12 inches. And the next month, it grew to 14 inches. So what is happening here? How is this changing? Seems like every month is increasing by 2. So what can you tell me about this? Is it increasing 2 inches for every month? So in word form, it seems like it's 2 inches per month. That is the rate of change. This is how this table is changing. So if I added another month, is it really increasing 2 inches per month? So we have another month here, and then we added 2 more inches, it'd be 16 inches. So this table is showing there's 2 inches per month. It's steadily changing at the same pace. And the last question. At 2 p.m., the level of water in the pool was 10 feet. At 6 p.m., the level of water was only 2 feet. Oh no, it dropped. So determine the constant rate of change. So how did it go from here to here? Well, let's add some times between it. 3, we have 4, we have 5 p.m. So how did it drop from 10 feet to 2 feet in a span of 4 hours? I think it dropped from 3 p.m. it dropped by 2 feet to 8 p.m. And at 4 p.m. I had to surmise, I think it dropped to 6 feet. And at 5 p.m. I had to guess it dropped another 2 feet to 4 feet. So what can you tell me about the change of this? Is it increasing or decreasing? It is decreasing. How is this decreasing? It seems like every hour is slowly dropping or decreasing by 2 feet. So it's decreasing 2 feet per hour. So from this, it seems like it's steadily dropping. Every hour it drops by 2 feet. So what we talk about here is constant rate of change. What you do is you look at a table, you look at a graph, or you look at a word problem, and you try to see how is it changing. How is it steadily changing? I like using the unit rates to help me solve it. Because in here, I found a unit rate. It's steadily dropping 2 feet per hour. In this one, this is increasing 2 inches per month. In this graph, it seems like the graph is increasing 10 miles per hour. So this is the rate of change, or constant rate of change.